Up until now, we've been assuming that we're working with a valid contract ID. But what if the field service agent fat fingers the contract ID as he's typing it into the system? He types it in incorrectly. How should our domain layer respond? We're not dealing with a valid contract ID, and we're not dealing with an expired contract ID. That would still assume that it's in the system. This is a contract ID that's not in our system. It's not stored in our database, essentially, okay? So let's think about that for a moment. What we're not asking is how will the user interface notify the user? We're talking about the interaction between the domain layer and whatever's calling into the domain layer. Most likely that'll be an application facade that's in turn being called by the presentation layer. The application facade will pass something back to the presentation layer or the web services layer, letting it know that I couldn't find this in the system. All right, so there are a couple of options of what we can do from the domain layer to enable this scenario, but only one that makes sense in my opinion. So here, let me tell you the bad option first, at least in my opinion. We could create an empty contract. So we couldn't find it in the database. We still create a contract object instance, and we pass that back from the service, the contract service, to the caller. Now, in the olden days, programmers would return codes indicating whether an operation was successful or not. The caller of the operation would then check the return code to determine if it was legitimate. That was the source of many bugs in systems because it wasn't obvious what each function could possibly return by just looking at the function's method signature. All right? By passing an empty contract back to the caller, we're relying on the caller to know our magic system, our magic numbering system. I don't like that. It's not explicit enough. A more explicit way of notifying the caller that the contract ID is not associated with a contract in our persistence layer is to return an exception. I like this because it forces the caller to deal with it, and there's no mistaking that what it is, that it's in response to a bad contract ID. So now we could use some generic exception and pass that back to the caller and then pass the description of the problem in the exception.description attribute. However, a better approach would be to create a custom exception specific to this scenario. So we're going to create a unit test to design this scenario and then implement a custom exception that will satisfy the unit test just like always. And there's some guidance in the Framework Design Guidelines book regarding custom exceptions. I've got the URL on screen and I'll make sure to paste this into the document or to the website. But essentially, here are a few of the guidelines. First of all, avoid deep exception hierarchies. Okay, no worries, we can do that. Do derive exceptions from system.exception or one of the other common base exceptions. Got it, we can do that. Number 3, do end exception class names with the exception suffix. Naming convention, we're all over that. Got it. 4, do make exceptions serializable. Okay, so we may have to figure out how to do that. An exception must be serializable to work correctly across application domain and remoting boundaries. Okay, so I get that. If we want to pass this exception across a domain boundary, if we wanted to pass this exception in a web service, then we're going to need to make this object, this new custom exception object, serializable. I get it. We'll have to figure out how to do that. And then number 5, do provide at least the following common constructors in all exceptions. And there's some code examples where I pulled this quote from, and so we'll just follow their little convention there. Make sure the names and the types of the parameters are all are the same as those used in the following code examples. See that on the page where I pulled these little quotes from. All right, and there's a few others regarding secure information. I won't need those, but make sure you reference that website or the book, this book, which everybody should have a copy of, whenever you set out to design your own custom exceptions. All right, so let's start by adding a new unit test. That's where we want to begin and drive this process. So public void get by ID, and what we want to test this time is the invalid contract ID. And we want to make sure that it throws an exception. All right, so how do we assert that an exception was thrown? Well, first of all, got to make sure that this is a test method by adding the attribute. But we're going to add a second attribute, and it's going to be expected exception, and then we will pass in the type of, so what class do we expect to throw, and let's give it a name. We're going to come up with this name ourselves. Contract not found, and then we need to add that exception suffix, right? Because the book told us we need to do that, or should do that, right? And so obviously we haven't created this custom exception yet, and it shows up in red, at least in my tool. All right. So there are two things to note here. First of all, notice the use of the expected exception attribute. This will allow us to say that this unit test should create an exception. And here's the exception class that we would expect to receive back. If we don't get an exception, or if the exception is not the right one, then we want the unit test to fail, to catch it. All right. And then secondly, I followed the naming rules of the framework design guidelines. I've added the suffix exception to the end, just like I touted a moment ago. I've also given a clear name to the exception, so there's no doubt what went wrong, especially in the context of the fact that it's been called by the getById, which is the method under test here, right? Before I implement it, let's finish out this test. So to do that, what I want to do is we're going to only call the act. And the act will be var contract equals contract service dot getById, and then we're going to pass in invalid contract ID. All right, now this should fail because we have not set that expectation up here in Fake It Easy. All right. Now I think that's all I have to do. I may need another line of code. I'm not really sure at this point. I may need to come back to it after I implement the contract not found exception. But I think that's all I need to do is actually just act, and that should trigger the exception. So let me go off and do this now. What I want to do is I'm going to add a new class. In fact, maybe I should even, in my domain project, I'm going to add a new folder first. So I'm going to add a new folder. I'm going to call it exceptions. And again, I could put this off into its own DLL, its own project. But for now, I'm just going to keep it here. And add a new class. And I'm going to call this contract not found exception .cs. All right. And the first thing that I want to do, per the encouragement of the Framework Design Guidelines book, is I want to derive from system.exception. And I also need to implement iSerializable, and I'll need to find that somewhere deep in the dark recesses. ReSharper helps me once again. So Alt, Enter, and there we go. We get the system.runtime.serialization using statement added to the project. If you don't have ReSharper, just add it in and type it in. Okay, and then I'll just do a to-do. I'll add the constructors here per the framework design guidelines. Okay. Now let's go ahead and run this, and we're going to get a problem here. Yes. The problem is back here in our contract service test, we cannot see it just yet. So what we should be able to do here is I'm just going to copy this line of code and I'll change it out with exceptions. That should work. Okay, it found it. It can't access the internal class. Okay, so I always forget to do this. Like so. Now it's public. And now it can see it. It's happy. So if we run the tests again, okay, it failed, but let's take a look at why it failed. Let's see. It did not throw an exception. An exception was expected. Okay, so we got a couple of different issues here. First of all, let us go into our our getById method, which is the method under test. Let's see, where is that? In our contract service. There we go. And what do I want to happen here? I'm actually, as I look at this, I have a moment of confusion when I go to implement this code, a little bit of angst. I'm not sure what will happen when I call getById with a non-existent contract ID. I may need to debug to see what the current behavior is in slow motion. So what I guess I'll do is I'll set a breakpoint here, and then what I want to do is I'm going to right-click and select Debug Selected Tests. And what I want to do is step to the next line of code, and then I want to evaluate and take a look at what we see here. So you can see that contract ID is null and the expiration date is 1/1 of 1. All right, so it's essentially a null date as well. So that gives me an idea. I've set expectations for non-exception scenarios using Fake It Easy. I wonder if I can use it for exception scenarios as well. So I say to Fake It Easy, when they give you a contract ID that says invalid contract ID, maybe I can return back something and act like it would be returning it back from the contract repository class that I'm going to create in the future. So I go back to the contract service test, and I'm going to go back up here where I have all these expectations. I'm going to add another one here. So a call to, and this will start off exactly like we've done before. So a call to contract repository getById, and this time I want it to be invalid contract ID. It should throw, and we want to use throws contract not found exception, like so. Let me split it out onto multiple lines so we can see it. There we go. And now let's go ahead and run all. And now we've got it to pass. In other words, whenever we're calling the getItById with an invalid contract, we have told Fake It Easy to make sure you pass back a contract not found exception. So what we're implying here is that we're going to put the burden completely on the repository layer to generate this contract not found exception. And so it'll just be bubbled up through our getById and back to whatever is calling it, and it will ultimately have to handle that exception. All right, so that's what we're doing here. We're not doing anything necessarily inside of our contract service itself. We want the contract repository to be the one that handles it. So when we go to create our contract repository, our actual contract repository in another series, then we'll need to create it in such a way that it will throw that exception for us. Okay? All right, so we're successful now. Let's do one little tidbit of refactoring here. I apologize that things got a little messy. I've had to re-record something, so let's change this back to the way it should have been. Get these here. I think I did undo too many times in Visual Studio. Just now discovered it. And then what we want to do is create another one. Like so. And here we'll get rid of that. And I think that's all we'll need to change this here as well. Great. Okay, much better. All right. Now, if you recall, I just stubbed out the exception. What we really need to do is create a full implementation of it. So I used the to-do moniker, and I can get back to all the to-dos by going to the View menu, selecting Task List, and if I change from User Tasks to Comments, I'll find the to-do there, and I can double-click it, and it will take us back here to our contract not found exception. And so now this is where I'm going to have to do quite a bit of typing. So, you know, in this case, I didn't really need any new functionality per se. I merely wanted to create a custom exception to differentiate the type of exception. Not because I want to override or add any new functionality to the exception class, but merely because I want to make sure that I can differentiate this type of exception from a different type of exception. That's the only reason why I created it and gave it a new name, contract not found exception. All right, but still, what I need to do is add the base class implementations for all the methods that I'm required to create because I've inherited from exception and iSerializable. So to do that, again, quite a bit of typing. Let me just kind of make some room for myself here. So one thing you might notice is that there's a base keyword that I don't think I've ever talked before in any video. I think that if you just take a look at the description of it in on MSDN here on this URL, you'll find out what it's there for and what purpose it serves. But if you take a look at the very top of that web page, it says the base keyword is used to access members of the base class from within a derived class. So call a method on the base class that's been overridden by another method. And here's the second one, which is most importantly for our purposes. Specify which base class constructor should be called when creating instances of the derived classes. A base class access is permitted only in a constructor, an instance method, or an instance property accessor. So I'm accessing the base class exception in the first three constructors, and I'm doing so to specify which base class constructor to use when creating instances of the derived class. So again, if we were to then create a new instance of our contract not found exception with both a message and an inner exception, then we want to make sure it's calling the correct base class implementation. All right. The last constructor here, this one at the very bottom in line 22, I use this to implement the iSerializable interface. So when I hover over the base keyword here, you'll notice that it knows exactly what I'm attempting to do. It initializes a new instance of the system.exception class with serialized data. All right. So I should probably create unit tests to ensure that, first of all, this is designed correctly, and then secondly, it'll work in the future after making changes to it. But I'm going to be a little bit lazy here. I don't see that that's going to get me a lot of value, especially at this point where I'm in a design phase. I believe in code coverage as close to 100% code coverage, which is simply a term that says how much of your code is covered by unit tests. And we should strive to get as much of our code tested with unit tests, and so something in the high 90s is desirable. But this is where one of those cases where the maintenance team, if there is one, can come back and worry about code coverage at a future date. Right now I'm spiking. Right now I'm trying to create an architectural spike, and I've got to move on. But the good news is that the hard part is over so far in creating this architectural spike, in my opinion. We've got a basic structure in place. We have our project set up. We've got we put a lot of thought into where things belong and the overall construction and what's going to contribute to making things work between the layers and how we're going to unit test. So the rest is just implementation of the user story and whatever comes after that. So in some cases, we'll expand on the direction we're already headed. And so I think we're in good shape. We'll start in the next lesson and add some more functionality and just reinforce some of the things that we've done up to this point. All right, so I'll see you in the next lesson. Thank you.